Hi, everybody. Piotr allowed me to give this talk in English. If there is somebody like really against, please speak now. But there is a couple of people who are not here, but would probably want to watch it later, and they're not from Poland, so I decided to give it in English. So yeah, the title is Trojaned Gems. Gems. You can't tell you're using one. First, I will tell why I think that the topic is important. Then, few words about how the Ruby gems are built. Then, about how the whole network mechanism of installing gems actually works. What are the security risks related to that topic? About signing gems, about the discoveries of my colleagues, and what can you do to actually minimize the impact of security risks. So the research was done by two colleagues from my big team, Brandon and Jonathan, and this research resulted in two CVEs, 3900 and 4020 from this year. I'm working in the same big department, let's say, but in other team, I'm working on a SIEM, which is basically a product that collects logs from various sources and collects them together, analyzes and stuff like this. I'm programming a bit in Ruby. We've got a bunch of internal tools, mostly in Java, legacy stuff, and there is a need to improve or rewrite some of them. So I'm experimenting with Ruby. I play piano, I sing in an awesome choir. I do analog photography, and I like eating and cooking. So why bother? Well, probably most of you are programmers, and I'm happy because I'm not. And it's always nice to meet other people who look on the same topic from different perspectives, probably. So this you probably know, as you are programming in Ruby, that there are many places where Ruby code is used for production. And here is like I put the record in quote. I will explain it in a moment, but basically this slide is just to give you the rough estimation about the impact of the vulnerabilities that I will be talking about. So only the OpenDNS infrastructure every day observes around 24,000 requests for this ASRV DNS record. And they are handling around 2% of the DNS traffic. So when you multiply this, it gives per day more than 1 million gem installs from the rubygems.org. So even if it's 10 times too much from this calculation, it would be still significant number. So I think the most important goal for me in this talk is to show you and encourage you to question the technologies that you are using. It's especially important if you are not working as a security person on your daily duty. You just have your stuff to do, and sometimes you don't think about stuff like this. And the vulnerabilities I will be talking about, they're already fixed, of course, but we all know that we've got a lot of systems that still run old version of software because of various reasons. Either we do not have time to update it, or we are not allowed and we asked sysadmins to do it and they have other stuff to do, or we are using old versions of operating systems and there is no upgrades from vendors and so on and so on. Yeah, because if you don't do this, the bad hackers can do you harm. Actually, this is me. I'm not a bad hacker. It was just these guys for this photo. So how many of you actually looked inside of the gem? Okay, cool, awesome. But not everybody, as I would expect. So apparently it's a very simple format. The gem file is actually a tar gzipped archive. It is built according to the procedure which is described in the gem specs. In the gem specs, you provide stuff like the gem name, version, author, the license, the description of the gem, what it does, and so on, and also the dependencies and the public key if the gem is signed. So I built a simple gem that does nothing basically, and if you look inside, it's just a tar gzipped archive, and inside there are 3 files which are again gzipped archives, and if the gem is signed, for each of them there will be a corresponding signature file. So metadata is obviously metadata. It's like the most important stuff that the gem program actually needs, and it doesn't have then to extract further and analyze the code itself to figure out some stuff, as you would expect. The data is basically your code. And checksums are the SHA-1 and SHA-512 checksums for those binaries. So building gem is very simple. You just run the gem build. You provide it with a gem spec file. In this case, I'm signing this gem, so it's asking me to provide a passphrase. The gem is built, and as you see, like now, we have for each of those files that we were talking about just a second ago, there is a corresponding signature file. And the distribution of software is very easy. There is a central server. I mean, you can, of course, set up your own one, but we are talking now about the rubygems.org. And the author is pushing his or her gems, and users are sending requests to the server, and they are served with gems. So basically the procedure looks like this, that you need to have the information where the gem files are expected to be downloaded from. And you can either fetch, which will just download the gem into the working directory and then install it, or you can install directly. So in a more detailed procedure looks like this, that first thing that the gem program is doing is it asks the DNS about the specific SRV record that I was mentioning at the very beginning. And the DNS answers what is the FQDN of the place that the gems can be found. It's quite useful because in the configuration of your gem, you just give the simple name like rubygems.org, right? But actually the server is not there. So the magic is done with this record, because actually the DNS server for the rubygems.org stores this specific record, and this allows to move the things around, basically to other servers, to other places, and you do not even notice, you do not have to update your configuration. You have all the time just https rubygems.org and nothing changes. So when the gem figures out where is the server with gems, it sends the HTTP GET request to find out what are the dependencies for the gem. It gets then the reply, and then it's able to build the whole list of gems that it needs to install, and sends the HTTP GET request to the server to get those gems. Yeah, and this is the record. I don't know if you see it. I can type it in the console, maybe in bigger letters. So it's like gems TCP rubygems.org. It's something like this. So if we ask, right, so actually it's the API rubygems.org. Although in my sources it's just the rubygems.org, right? So that's this whole magic. The DNS server just keeps this SRV record, and the owners of RubyGems can tune it according to the needs. Yeah, sorry, this is probably not readable if you see it far, but this is fragment of the TCP dump from actually installing the gem, and this is the piece where you can see that the server that the client is communicating with the API rubygems.org. And then what are the security risks for this kind of communication? So first of all, like obvious thing would be if you can try to cheat this SRV record somehow to convince gem to actually download packages from some other place. Other options are if you can somehow sit inside, do the man in the middle, and try to change the server's reply with the dependencies, right? Because if you can, then you can force the gem to install some other packages as well, right? The user wants to install some gem, which normally has the dependencies A, B, and C. And if you are able to convince it that it should also install the gem D, then you succeed. And you can also, of course, try to alter the contents of the gem itself. So all of those scenarios assume that you are able to do one of the things, which would be either trying to do to spoof the DNS somehow to send your answers and make the user's gem program to believe that they are correct, or various scenarios for man in the middle attack, trying to hack either the DNS or HTTP protocol. For the coffee shop scenario, it's like, you connect to the network, and how many of you check what's the DNS that you obtain from the DHCP when you connect to a network? Yeah, sometimes we do this, but probably not very often. And another variant of this would be, quite recently, I think a couple of months ago, there was a bug in firmware of one of the modems that was used by one of the biggest internet provider in Poland, which actually allowed attacker to put their own DNS servers information to the modem, and then when you were connecting your computer, you were using basically this DNS. So it's kind of this scenario. So yeah, this first idea, trying to hack the DNS reply, is basically like this. We are asking where is this nice gem shop, and we get the information back that it's here. Man in the middle. Well, actually, that was also man in the middle. So yeah, you can try to cheat and fake the dependency information, right? If you are able to capture this GET request for gem dependencies, of course you forward it to the gem server. Server replies back, but then you alter this this result, and you forward to customer to user the altered dependencies information. And here, like, the idea is very similar, but you are actually altering the gem itself, right? Not the list of dependencies, but you add your payload to the gem itself. Yeah, and the goal is to convince a person that this is a genuine Windows, right? It's not a pirate. It's certified and original. Yeah. So for first demo, the scenario is that actually it's important. I will mention it again near the end, that we need to use the HTTPS. Like, this is the whole trick, because if we use the HTTP, then we are just able to do all this stuff that I just told about without any vulnerability in the gem itself, right? If you have just the HTTP and right, if somebody in the gem sources have the HTTP, then it's very easy, and you do not need to actually exploit anything in the gem command itself. So yeah, user uses the rubygems.org as a source, and everything is encrypted, so we think we are safe. So the attack looks like this: that user runs the gem install command, and attacker alters this asrv record reply and points user to malicious gem server, and then user installs attacker controlled gem. So this is our fake server. Let me okay, cool. So the address is 10.92.211.137, and this user right, this is, we are pointing to this name server actually here, the same IP. So let's do a quick check, because we are faking only this asrv record. So if from this user I do the ping rubygems.org, it's probably pings are blocked. I'm in the lab network, but like you see, it's public IP. It's the IP of rubygems. I can try to ping the API as well. Same, but if I do the dig for this record, right? So that's the trick. That my DNS server just altered this one record only. So if this user has the browser, he can browse web normally. He can go to the Ruby Gems web page. Everything looks normal until he tries to actually install something. So let's do the gem fetch. That's a gem that it's only on our internal server. This gemstrustwave.com. You won't find it on the. Yeah, I don't know. Yesterday I had the same situation. I don't know. Maybe the server is rebuilding the list of packages. I had very same. No. It wasn't working for 10 minutes, and then it started working. That's it's always like this with live demos. Yeah, that's that's possible. Okay, but I'm prepared. So this is the same situation, but it's recorded, right? Yeah, so exactly same story. Right, and again the record is altered. Yeah, the server is started, and we are trying to install the C7 decrypt, and it's actually installed from our gem server, not from the rubygems.org. Oh, I'm really sorry that that's didn't figure out what's the problem. Maybe we'll try a bit later again. Yeah, so the demo just happened. So yeah, this discovery resulted in the CVE 3900. It's fixed in Ruby Gems as versions as mentioned here. So the homework for you is to do as the very first thing in the morning to check on all the on the systems you use with Ruby Gems that you have at least this version, or actually even larger version of Ruby Gems installed. To fix it, of course, you need to do the gem update -- system, but there is a problem with this, right? Because if somebody actually attacks you at this moment, then you will be downloading the altered software already. So it's kind of chicken and egg problem, right? But unfortunately, nothing can be done with this. Maybe I will show this. Will be easier. Make it not. Is the size okay now? So how was it fixed? So the check for the API 8 endpoint works like this, that we are passing the URI which is basically what you have configured as your gem source. So in our case, it would be rubygems.org, right? Then you run the DNS query to obtain this underscore rubygems dot underscore TCP dot and then the name of the host from your configuration file. And this red part, right, with the minus, because it's a div. So how it worked before was that it actually created a new URI for you using the same scheme that you had in your configuration file. So in our case, HTTPS. And then it just was putting the target of this DNS query, right, without checking anything. So the fix was obviously then to compare if the host from your gem configuration actually matches the target returned from the DNS query. I mean, if it's from the same domain, and if not, it was just returning back the original URI. If it matches, then you are fine. Then it means you are safe. So turns out that it was not correctly implemented fix, because this code that you just saw allowed to do something like this, to redirect somebody to not rubygems.org, or even to some, basically this was not very good string matching. Luckily it was discovered. It was, actually it was discovered very quickly. So the new CVE was created for this, and if you compare its bump of this last digit inversion for all the Ruby gems. So actually this is the homework for you, to check that you have at least those versions. And again, game update, and again the problem of chicken and egg. So here I hope you see it. It's changed to be more strict about comparing the hosts returned by DNS query. So you would say that, okay, nice, but how somebody would know which gems I would like to install? You are not going to just Trojan all the gems that are available on the rubygems.org and wait until I install them, right? So the second demo shows that it's actually quite simple to build your server, which would capture, as I explained a few slides before, that would just capture your request, fetch the gem from the rubygems.org, rebuild it, and serve you altered one. So this demo I have definitely, I will show you recorded. Let's try this one. So let's make it full screen. Okay. Yes, so we're using only the rubygems.org. Here we are running our fake server. We want to install the C7 decrypt. Yes. And as you see, server just rebuilt it. Yes, so we actually installed the altered version. So as you see, it's quite possible to do something like this, and you do not need to wait and guess which gems your victim is going to install, because that indeed would take ages. So you would say, okay, cool, but we can sign the gem, right? It's super cool. So even if we use just HTTP, if we sign our gem, then nobody can alter it. But first question is, how many of you sign your gems? Cool, congratulations. So how many of you heard that it's possible to sign the gem? Yeah, more people, definitely. So the problem with current gem signing infrastructure is like with the PGP in email, right? So the signature needs to be trusted by you. So if I build my gem, I generate for myself the signature, I sign the gem, you want to install it, and you receive the information that the gem is signed by some Jarosław. And how could you know that it's actually really me and who is Jarosław at all, right? So that's probably the reason why not everybody is signing their gems, right? So there are many different models, right? Because actually installing gems is not the only one feature like this, where people install software from remote destinations. So I don't know, for example, if you have Linux distribution based on RPMs, I guess with deb packages it's the same, they are signed, right? But they are signed by the vendor. So actually if you install Red Hat or Fedora or Debian or Ubuntu, the keys are there already. So when you install the package and it doesn't, raise any error, then you are sure that it was actually signed by the vendor. And if you're adding some other source of packages, then of course you need to trust this certificate, but again, only once, right? Because the certificate is per server normally. The RPMs, for example, from RPM Forge, they are built on their infrastructure and all of them are signed with the same signature. So actually you need to trust only one signature. Whereas here, everybody can upload their packages and sign with their own signature, which makes it really problematic because a gem has dependencies. Those dependencies have their own dependencies, and the tree grows, and each of them are signed with different signatures. So that's I think is the reason why you do not sign gems, and it's not widely adopted feature. But actually it's very, very easy. You just need to generate a certificate for you and just add 2 lines to the gem specs file, and then you just build gem normally. And when you install, so like this first part is installing the gem that is not signed. And if we specify that we want to use this high security policy, then it fails, right? It says that the gem is not signed and it refuses to install it. So this other one is already signed. Trust policy, high security, success, yay. Right, so yeah, my question about if you sign gems, actually, you shouldn't feel bad if you don't, because none of the 10 most downloaded gems is signed, and I suppose that probably even the top 20 or top 30. And as a result, it's not possible in real life, mostly, to set your policy when installing gems to high. So there is a workaround. You can use the medium security policy. Does anybody know how it works? Cool. So it is very interesting because what it does, it only checks the signature for those gems that you specifically wrote as the stuff that you want to install. But it doesn't check certificates for the dependencies. So of course, then it's possible to hack it, because if you have this infrastructure of playing man in the middle and altering stuff as they go through your computer, even if the gem that the user wants to install and all the dependencies are signed normally, you can just fake it. Like write this dependency number 4. You can just capture it when it's coming from a real server, and you can build your own version with the payload, and you can just provide it to the user not signed. And as long as they are using the medium security policy, it will work. So yeah, this demo shows exactly this. We want to install the gem which is signed. We want to use the medium security because we know that not all the dependencies are signed. And attacker just uses this chance to send us as one of the dependencies the gem that is altered. Okay, so let me do the full screen again. Yeah, so here is our server listening. Yeah, we have only the rubygems.org. We have a certificate added. Right, we installed the package. Gems are installed. And this dependency 3 was altered by us. And we just received the warning that it's very easy just to miss that one of the dependencies was in fact not signed, but it installed, right? So personally, I'm very skeptical about this medium security feature because it gives you the false feeling of being secure, that you think, oh, nice, I use some signed gems and I use some kind of security policy. So it's very arguable if this is better than nothing or actually not. So recommendations for you. Again, I will emphasize the need of changing immediately all your gem sources to be HTTPS, because like those attacks that I just shown, if you are using the current versions of gems, are not possible using HTTPS anymore, right? But if you use HTTP, they are still possible without, without trying to compromise the gem itself. Yeah, this is with the trust policy again. Like actually, it would be best to use the high security. For developers, same story when it goes to gem sources and updating the gem itself. And you should start signing your gems, even if most people will just ignore it. but if there's enough people doing this, maybe it will improve the situation. And the other interesting thing is the update framework. It's a bunch of guys who figured out that actually there are tens or hundreds of different software projects that are trying to somehow provide updates to their users. So this, like for programming languages, you've got stuff similar to Ruby gems in every language almost. You can have software updates for any other piece of software that users have on their computers. So they figured out that maybe it would be nice to build sane and secure documentation and standard and libraries for providing updates. So the work is still in progress. I was just reading their page yesterday, and looks like Puppet is actually now in progress of implementing this stuff and helping those guys to build it. So yeah, maybe that would be the solution. Maybe it would be a bit more secure than the current situation where everybody is trying to implement this same feature of providing software updates themselves. So I will probably put the presentation somewhere. I think that they are usually on the page, right? After so I will send it if you would like to check out some of those links. So the link to the presentation of founders of those vulnerabilities with a nice blog post about it, information about how to sign the gems, awesome talk by Ben Smith from Aloha Ruby Conference 2012 about actually Trojaned Gems, and this update framework I was just talking about. Questions? Okay, cool, thanks. And sorry once again that the demos didn't work. Yeah. Okay, awesome. Thank you.